Hello, you guys. Good night, good morning, good afternoon, good evening, whatever time you're seeing this video. My name is Fernando Melendez, and I would like to officially welcome you to Biology 1124. I will be your instructor this semester. Only if you're in sections 34 or 51. If you're on another section, I'm sorry, you clicked on the wrong PowerPoint, but don't worry about it. It happens to all of us. But if you are on section 34 or 51 officially, welcome to the course. And we're gonna have a lot of fun. And most importantly, you guys are really gonna learn. So let's go ahead and start with the presentation. This is a very brief presentation just to do an overview of what we'll be seeing this semester, how's the schedule, and we're gonna be talking a little bit about experimental design towards the end, but don't worry about it. We'll cross that bridge when we get there. So general information about the course. This is Biology 1124 for sections 34 and 51. Since we're online, you don't have to do the freshman walk of shame when you stand up in front of everybody because you got to the wrong section or got to the wrong classroom. But yeah, if you're not from those sections, again, log off this presentation. Don't worry about it. Your instructor did one for you. But if you are, welcome again. My name, Fernando Melendez. And over here you have my email, fernando.melendez1@ou.edu. Feel free to write me at any time. My office hours are by appointment. Usually I'm free and ready to meet whenever you guys are ready. So at pretty much your convenience. I do in-person meetings if you guys prefer that, or if you want to do Zoom meetings. Again, I'm down for Zoom meetings also. And I have my cell phone with me 90% of the time, so I respond to emails as quickly as possible. And if it's a question that I feel I can answer it by email, again, feel free to contact me anytime. There's not a bad question, and I always like interacting with my students, so please feel free to hit me up on the emails, whatever. I'm gonna be there. Yeah, a little bit about me. You can detect a little bit of an accent. It is because I'm Latino. I am from Puerto Rico. I am a marine biologist from there, actually. I did my undergrad in general biology, and then I did my master's in marine biology, both at the University of Puerto Rico. I've been teaching for about, I say, 2.5 years in Puerto Rico. So I'm used to teaching in Spanish. So again, I'm sorry if you guys can't understand me. Obviously not here, but when we're in person, raise your hand. Fernando, can you talk a little bit more slower? Can you repeat it? I'm cool with it. Don't worry about it. I know that English is not my first language, so please feel free to correct me or whatever. Don't worry about it. Again, I'm a marine biologist from Puerto Rico, so you might be asking, why is a marine biologist in Oklahoma, a landlocked state? Good question. As you can see, I'm losing my tan already. I used to be tan, but not gonna lie, I'm loving Oklahoma so far. My main area of research was ecology and marine protected areas, so I'm very into conservation, population dynamics, statistical analysis, graphs. I did a lot of effectivity assessments, so I just went down, did diving, counted the fish, and then determined if marine protected areas in Puerto Rico were being effective or not. And my PhD here in Oklahoma is a little bit different. It's more geared towards genetics or evolutionary biology. I'm gonna be finding out the origin of endothermy in tunas. Endothermy is the ability of having warm blood across your body. So I wanna see what are the genes responsible for endothermy. So yeah, I'm the tuna guy. I've been the tuna guy for about 1.5 years now. People have called me Big Tuna, and I've never understood that joke until I saw The Office for the first time about a month ago. So yeah, I'm finally with the crew. I still haven't seen Friends though, but yeah, I saw The Office, laughed like hell. You can call me Big Tuna if you want. I'm not stiff. You can call me Fernando, Fernan, whatever, as long as we treat each other with respect. I treat my students with the utmost respect, and I expect the same from my students. But I'm very laid back. I'm not. You don't have to call me professor or instructor or anything. You can call me Fernando. But of course, always maintaining that level of professionalism and respect. But yeah, pretty much, like I said, excited to be here in Oklahoma, excited to be teaching you guys. What will we be doing in this lab? We will apply biological concepts while using the scientific methods. We will learn how to design experiments. You're in luck. That is one of my main areas of expertise, experimental design. So I'm very good at designing experiments and teaching experimental design. So hopefully you're in good hands with me. And of course, be creative, collaborative, and have fun. And you guys are saying having fun on the lab. Trust me, I've been there. It's hard, but I try to make jokes. I try to keep the class, as much as awake as possible. But yeah, hopefully we'll have fun, and more importantly, we'll learn. Keep in mind that I'm very aware that 90% of my students, if not more, are interested in pre-med, farm, uh, dental, something health sciencey related. But I also have business majors. I also have biology majors. So again, nothing different than what I had in Puerto Rico. So if you guys have any questions regarding your field, including the business majors, I did deal with a lot of business majors in Puerto Rico, and I really enjoy teaching them. Please feel free to come by if you have doubts for research. If you're a pre-med student and are worried about the MCAT or worried about any other exam or the process of applying to med school, again, I've not applied to med school myself, but I've taught a lot of people who did apply to med school. And again, I can help you in any way I can. And if I can't help you, I'm pretty sure I can send you to somebody that can. So yeah, feel free to talk to me about anything regarding your studies, interest. If you're undecided, you're in luck. With me, you're gonna find your passion, hopefully, either in biology or in any place else. I try to incorporate different examples from different fields. So it's not always gonna be talking about medicine. It's not always gonna be talking about fish. It's not always gonna be talking about the same topic. I like to see if you like theater, I try to pick an example that you might find interesting. If you're in business, I try to use business examples. So again, pretty much all around here. So feel free to contact me at any time. I'm a student like you guys, so relax. This is the schedule for this semester. It's a little bit complex. I get it, especially with all the coronavirus stuff. When are we gonna get classes? Are we gonna go full online? What does hybrid mean? Why are some people online? Why are some people in person? Don't worry about it. Here, I have it for you. I'm going to explain it. And if you guys have any doubts, please send me an email, or when you see me in person, hey, Fernando, can you please explain the schedule again? But keep in mind that for each section, section 34 and section 51, I have divided both sections in two, either group A or group B. So they will be in the same lab, but they will not be doing the same activities at the same time. So for example, here we have week 1, which is the week of August 24. And we have the online lab introductions, which are for both groups, group A and group B. So you guys are seeing this video, you guys are gonna do the activities for this video, and then by Friday, you will do the assignment. That's cool, don't worry about that. I will explain that later. But next week, you see that there is a WL and an OL before the activity. Well, that means wet lab or in person or online lab. So next week, the week of August 31st, Group A will be seeing me in person, while Group B will be staying at home doing an online activity. Now, after that, we'll switch around. Obviously, the week after that, we don't meet. But after that, the Group A, which did the wet lab with me, will now do the online activity that Group B did the first week, and then Group B will do the in-person activity that Group A did with me the first week. So we'll pretty much be switching around week from week. So we'll see each other in between weeks. So for example, Group A, we will see each other in person on week 2, but we won't see each other again until week 5, and then until week 7, until week 9. So just keep this schedule handy, simply to review, okay, do I have to go to lab today, or is today an online activity? How do online activities work? It pretty much works the same for everybody. The online activity will open on Monday, regardless of the day that you have scheduled your lab. So if your lab's on Wednesday, on Thursday, or Friday, it doesn't matter. The online activity will open on the first Monday, on Monday, August 21st, August 31, September 7, whatever, and will close on 5 days, meaning in Friday or around 12 p.m., the activity will close. So you'll have a total of 5 days to do your online activities. For the wet labs, it will be different. You'll show up in person, you'll do a quiz, we'll do the lab in person, and after the lab, you'll hand in the work that you needed to do that day, and you're done with it. So in 3 hours, we're done. The online, we have 5 days to do it. Don't worry about it. We're gonna talk a little bit more on the following slides when I talk about classroom dynamics, what to expect, what are the quizzes about, what's the difference between online and wet lab, whatever. Don't worry about that. For now, just know the schedule. group A or group B, depending on what group I assigned you to. You will have online or wet lab activities depending on the group you're assigned. So for section 34, these are the assigned groups. So in group A, we have Taylor, Marissa, Shia, Grace, Kennedy, Anthony, all those people here. The name of the person beside you is going to be your lab partner for the rest of the semester. So for example, Taylor here is paired with Marisa. Shira is, I'm sorry, I hope I said your name right, it's not Shira, is paired with Grace, Kennedy with Anthony, so on and so forth. So you guys are group A. You're going to be seeing me in person next week, the week of August 31st. If you are section 34, I believe it's Thursday at 3 p.m. And if you're group B, you're going to be doing the online activity the following week, and we won't see each other in person until the week of September 14. Again, the Thursday of that week, of week 4. Sorry there. And if you are in section 51, which I believe is my Friday section, these are the groups. In group A, you have Kia, Alice, Reese, Anthony, again, all those persons. And in group B, you have Corinne, Abby, Kaden, and the same thing applies. Like Kia is partnered with Alice, Reese is partnered with Anthony, Corinne is paired with Abby, Kaden is paired with Clara. Those are your partners for the rest of the semester, except here for my friend Jared. I'm sorry, Jared, you still don't have a partner, but don't worry, we'll figure that out. I have a plan, so you're not going to remain partnerless for the semester. You're going to have partners. Don't worry about that. But again, sorry, Jared. Yeah, if you have any questions of the schedule, again, just send me an email, and hopefully I'll be able to help you with that fairly easily. What are the course policies? What are the rules? Well, everything's going to be available on Canvas. All you guys have already been enrolled on Canvas. You can go there. All the assignments are going to be posted there. All the presentations are going to be posted there. All the things that you need to bring to the wet lab are going to be posted there. All the online activities are going to be posted there. So pretty much Canvas is going to be your central hub for activities and coursework. Please, on Canvas, you will find the course policies. Read it thoroughly. Please, I beg of you, if you don't understand something, if you don't understand the schedules, if you don't understand the procedures, let me know. You'll find the syllabus there. It will tell you everything. It's the syllabus is paired with the course, with the main class, so you're gonna have everything there. And again, pretty much the policies for any lab applies, like don't eat, don't drink, don't smoke on the labs, wear closed-toed shoes. So yeah, the policies are pretty self-explanatory, but if you do have a question, just let me know. For example, what happens if you miss a lab? I would not recommend that you miss a lab unless you're very, very sick. Usually you miss the points for that lab. So again, I don't want you guys missing any labs. Always be honest with me. I operate on an honesty policy. Hey, Fernando, especially for those on the Friday. Hey, Fernando, I went out, hang out with my friends. I got drunk. I didn't wake up. I understand. I have students before, and you know, we've all been students. So yeah, I mean, just tell me the truth. We'll find a way to work around it. But please, please, please try not to miss a lab. And what assignments are required for admission to the lab? So usually when we're doing wet labs, that means the labs we're going to be seeing each other in person, you're always going to be required to bring a printed sheet, which is usually a pre-lab sheet with some questions. You answer those questions, you hand it to me at the beginning of the lab, I verify it, I give it back to you. And those pre-lab sheets are the instructions for the rest of the lab. So it's just following step-by-step instructions. I'll be there to guide you anyways. So usually to enter the lab, you're probably almost 90% of the time gonna have to bring that printed out with those questions answered. Because again, it is important for you to understand what's gonna be happening in that lab. And at the beginning of every lab or online activity courses, meaning that pretty much every week you guys are going to have quizzes, either in person with me or online via Canvas, or in this case, well, Top Hat in both places. But some people are going to be doing them online one week while others are in person, and then we switch them back. You already know that. The lab quizzes will be held at the beginning of every meeting, and we'll do them via Top Hat. Top Hat is an application. It's a software. You guys can do it in a website. You go tophat.com, and you can sign up as a student. You can download the app on the phone. I used to use it in Puerto Rico also. It's very good. Simply log in. The quiz will be posted there. You guys will do it. It will give you the grade automatically. You guys have the grade there. You guys have the quiz there, and we'll just start with the lab as soon as everybody's done with the quiz. For Top Hat, I will send you a separate email with the course code and the instructions for signing in. Usually, Top Hat is a paid program. I think it's like $5 a semester. I know that OU is working something out with them. So for now, just know that we're going to be doing them in Top Hat for the first week, which is this one. We don't not going to have a quiz, but next week we will. So yeah, usually maybe around the week, I will send you the link with the course code and everything. And again, don't worry about that for now. I'll take care of that on another email. And if you're doing a wet lab or an online lab, written summaries of the week's investigation. So a summary of what we did in that lab, what were the major findings. On the email that I sent you, or I still haven't sent it to you guys yet, but I will send it to you. And when you see this, you probably have that email. I gave you instructions and a criteria of how to write a summary. So it's fairly easy. You just do it. It don't take you that much. And that will actually serve as a substitute to lab reports. So we don't have to do any lab reports. We're only going to be doing summaries because it's a little bit easier to handle. And posters, presentations via Zoom of an experiment you've completed the semester. At the end of the semester, we'll do a presentation like we almost usually do. Almost every lab does it. We're gonna pick a topic, we're gonna do an experiment about it, and you guys are just gonna show it up in a meeting here, just like I'm doing right now. Just to clarify something, every activity that's online, and I just wanna reiterate it, because I know that some people might not understand that everything that's gonna be online, meaning that the online lab part, gonna start on Monday, gonna end on Friday. You guys have 5 days, regardless of the day you take the physical lab. So if you're in section 34 and you take Thursday's lab, or if you are section 51 and you take Friday's lab, for online purposes, it doesn't matter. For online purposes, the lab starts on Monday and ends on Friday. So if you are assigned an online activity that week, please do it in the period of 5 days. Everybody, regardless of the date, will start on Monday and on Friday, because hopefully not, but if we have to go fully online this semester, it's easier to have every lab, working at the same time on the same time frame, rather than having different sections scattered around, doing different online activities on different weeks. So we're trying to keep it, as equal as possible in terms of everybody starts on Monday and ends on Fridays in terms of online activities. Wet labs, don't worry, come, show up, do the summary, take the quiz, let's go, see you. But yeah, again, if you have any doubts, don't worry about it, let me know. What resources are available on Canvas? Like I said, Canvas is everything. You're gonna find the lab manual, you're gonna find the syllabus, you're gonna find the schedule, you're gonna find tips, you're gonna find assignments, you're gonna find your grades. So it's, again, like I said, the central hub for everything related to this course. All the assignments will be uploaded there. All the presentations that I need to upload will be uploaded there. So please always keep an eye out on Canvas. I like to send emails also to remind you guys, but I don't always do it because, again, I don't have to. I just do it because I like it. And some weeks I'm just so full of work that I don't send anything. But it's always going to be there on Canvas. You guys are going to get notifications. So please keep an eye on Canvas. And if you have any doubts on navigating Canvas, Canvas doesn't work for me in my phone, whatever, again, send me a message and I'll be able to help you. And if not, I'll send you to OUIT, and they can pretty much take care of any technical problem that you guys might have. And like I said, the investigation modules, that's what you're gonna have to bring printed before the lab, which is the lab background, the procedure, and the tutorials. The tutorial videos only applies to the online part, but the lab background, the procedures, what we're gonna be doing on that wet lab that particular day, or in that online lab that particular day, you need to do that stuff. You need to hand it in, and this information is fair game for lab quizzes. So the investigation modules are going to be where I'm going to be pretty much taking all the questions from my quizzes. So be sure to study that, be sure to come prepared, be sure to answer all the pre-lab questions that are necessary, and you're gonna do good. If you study with me, I'm the easiest one. If you follow me, if you study, if you're responsible with your work, you're gonna pass my class, you're gonna pass this lab. But if you fall behind, if you're irresponsible with your work, if you are not following Canvas, it's gonna be an uphill battle. But again, I'm always gonna be here to help you guys, but you have to put, a little effort yourself too. Lab safety in times of COVID. I know we're on uncertain times. Everybody's scared with the COVID, myself included. So yeah, masks are always going to be required as soon as you enter the lab, as soon as you enter any building actually in the OU campus. So yeah, we're always going to be wearing a mask when we're inside the laboratory. And we're also going to be wearing safety glasses, goggles, or face shields with our mask. Okay, so we have our mask. We're going to put the face shield or the goggles, whatever, but the mask will stay on always. If you have prescription lenses or prescription eyeglasses, those are not gonna cut it. I mean, you're also gonna need to put some goggles in front of those prescription eyeglasses or a face shield. The thing is, you need a mask, a face shield, and some goggles if you don't want the face shield. I will be doing the mask and the goggles. I got the goggles from Amazon. They're like $1 each. If you guys have trouble finding the lab goggles, just send me an email. I'll send you the link from the Amazon store page and you can buy them from there. They're very cheap. They're plastic, so they look like this. Like, they're very cheap to come by, so don't worry. You're not gonna have any problem finding them. But please keep in mind that if you guys are not wearing a mask or not wearing proper eyewear, you can't take the lab and I'm gonna have to count you as absent. So please, I always try to bring a couple extra masks. I'm gonna try to bring a couple extra goggles, but always bring your own just in case. We're gonna wash our hands often, obviously. Wear closed-toed shoes, meaning that sneakers or whatever type of closed-toed shoes that you have are gonna be good. Don't come in sandals, don't come in open-toed shoes, don't come in ballerina-style shoes, because it's more than COVID, it's lab safety, because if we work with some dangerous chemicals and we have a spillage, so I don't want you guys getting hurt. No food or drink in the lab. If you have your water bottle and you want to take a sip, you're going to have to stand up, go outside of the lab, remove your mask there, take a sip, put your mask on, and then come back to the lab. So please be mindful of social distancing measures and that you're in a lab with other people that might be immunocompromised or might not be as healthy as you are. So just out of respect, if you want to do something without your mask on, just leave the lab for the moment. Don't worry about it. You're not going to get in trouble for that. And obviously, keep phones away. I'm very chill with my phone policy. I've always been a type of teacher that just treats his students like adults. So if you want to be on your phone all the lab, be on your phone all the lab. If you want to be texting or in Instagram, it's your loss. You're not going to learn. And at the end of the day, when the course test comes, with the main class test come by, or if on the quizzes, it's going to show. So again, I usually try to make my class as dynamic and as entertaining as possible. So I barely get any cell phone usage. But keep in mind, I'm not going to call you out if you're using your cell phone. I'm just, well, if you ask me a question and I see you using your cell phone, I'm not going to answer it because you should have been paying attention. Again, it's all about respect. I respect you guys respect me back. Other than that, if you got to take a call, go ahead, take a call. Go outside the lab, talk. I know emergencies happen. Or if you want to text something to your mom, to whatever, because something happened, again, I'm chill with it. I'm not going to call you out on it. But keep in mind that I'm always watching and I'm, know who are the students that are paying attention, who are the students who are really there just to get by. Now, let's do a very simple experiment just to give you some practice, just to get warmed up of what we're going to be seeing on this semester. We have a case study here. The USDA, the honeybee researchers have reported a decline in population. So we have a lot of bees and now their populations are going down, down, down. And we want to know why. And as scientists, we are going to ask the question, like, for this problem, why are the population of bees declining? Something that I did with fish. I had the same question with fish. So you guys go ahead, think about some probabilities. It might be because of this, it might be because of that. Like, for example, it could be because of global warming, temperature changes. We could actually introduce an invasive species, another predator that's killing the bees. Might be human interaction, might be people killing them because we moved into that area and just, I hate bees and I kill them, whatever. Could actually be pesticides we're using. And all of these are possibilities: introduction of a new predator, several years of hot weather, environmental toxin, parasitic diseases. There are a lot of possibilities, but there's usually some right answers and some wrong answers. So we want to find out what the right answers are. In order to do this, we have to do an experiment. We formulate a question, we see something, we gather up some possibilities like we did here, and now we're going to do an experiment to see what, out of all of these possibilities, which ones are the correct ones and which ones we were wrong. Human disturbance is another one. Here, the USDA blamed the bee shortage or the population decline on pesticides. So that was their guess. They did an experiment based on it, and they figured out, hey, we were right all along. It was pesticides. So because the pesticides contain this chemical right here, it was derived from nicotine, and we're still not sure if it's lethal to bees, but we're sure that it probably affects other factors, maybe making bees more lazy, maybe it makes them sicker, less healthy, maybe it makes them more fat or more thin. But we do know that that pesticide is involved. They guessed it was the pesticide, they did an experiment, and then they get their results. But how would we be able to tell if the bee populations were due to this pesticide? How are we going to be able to prove it? We assume it's the pesticides. What steps are we going to do to prove that the pesticide is actually lethal to bees? And this is where actually experimental design comes in. This is my area. How are you going to do that roadmap, that step-by-step instructions? Okay, we're gonna do this with the bees, then we're gonna do this with the bees, then we're gonna count this, or then we're gonna do that. For example, my research, when I wanted to see fish decline, I went to different areas of Puerto Rico. I dove there, I counted the fish, and then I started guessing, okay, maybe they're declining because of anthropogenic stress, maybe it's humans, maybe it's pollution. Then I went back and measured pollution levels, then I measured temperature, and I went just like Sherlock Holmes right there, you know, deducting, okay, this isn't it, this isn't it, this is it, this is a probability. So this is what they did actually. They saw the population of bees declining. They guessed, well, not guessed, they hypothesized that it was pesticides. Now they're ready to prove to see if pesticides are the real cause for the decline we are observing. So what questions would we ask? Why the population's been decreasing? That's pretty much self-explanatory, but we can actually ask a lot of other questions like, why are bees becoming smaller? Why are bees lazier? Why are bees fatter? Why are bees stinging more than they usually do? So there's usually a lot of other questions you guys can ask, not only population related. Now, with a hypothesis, it is important that we know what the definition of a hypothesis is, because there's a difference between a hypothesis and a prediction, and we sometimes, even us scientists, don't know it. Usually, a hypothesis is a casual explanation. This is happening because this is there, or this is happening because of this change, or because of this disturbance, or because of this, whatever. So for example, a clear hypothesis would be exposure to neonicotinoids is causing the bee population to decrease. Bee populations are decreasing because we have exposure to this chemical right here. That's very viable hypothesis. So what differences a hypothesis from a guess, from a prediction? Well, a hypothesis or a casual statement means that it can be tested. It can be proved either wrong or right. You can do a test, you can do an experiment and prove if it's wrong or right. So for example, for the bees, we wanted to see if the pesticide exposure killed them. So we could do an experiment. We could put some bees and expose them to the pesticide and see if it kills them or not. And we can put some other bees in some other area with no pesticides and see if they die or not. If they die because of pesticides, whereas most likely pesticide exposure is what kills the bees. But if I expose them to pesticides and they die, but I also put some bees that are not exposed to pesticides and they also die, probably not the pesticide's fault. Maybe it's something in the environment, maybe it's something where they live. So we have to be able to prove that our hypothesis is either correct or incorrect. again, just using my research as an example, I saw the fish decline, the fish population decline. I hypothesized that it was anthropogenic stress. I did the research, I did the experiments, and it turns out I was wrong. It wasn't anthropogenic stress. It wasn't man-made global warming. It was a whole other stuff, including a little bit of human warming, of global warming, but there were some bigger stuff affecting that fish population who were only made worse by climate change, but it wasn't the main source. It was more like a governmental decrease. The people were not monitoring the area well enough. So it was actually more businessly, more politically related, but it was also anthropogenic climate change, but not to the extent that I predicted. So a hypothesis could actually be wrong. And that's what the experiment is there for, to prove you either right or wrong. Then if the hypothesis is wrong, I go again, formulate another one, test for that hypothesis. And if it's wrong, I do it all over again. And if it's right, it's right. Hooray, we did it. We found out why the fish were declining, or why the bees were declining. Now here, for example, this hypothesis will usually contain the words cause or because. This is happening because this is here. This is happening because we introduced a new species. So bee populations have declined because of insecticide exposures. Again, that's a very good, very fair hypothesis. You expose the bees and see what happens, and then prove your hypothesis right or wrong. Usually, and I put myself here too, because in grade school and in high school, they show us, or they tell us, that hypotheses always start with if and have a then in the middle. So if this happens, then that will happen. If I have money, then I will buy a sports car. If I am fat, I am going to have heart problems. If I am skinny, I am going to whatever. You know, that is actually not a fair hypothesis, because sometimes you can't actually even prove it. It's more of a guess. It's more of a prediction. If I have money, I'm gonna buy a sports car. I might buy it. I might not buy it. If I am skinny, I'm gonna be able to run a mile in 6 minutes, and I might be skinny and run a mile in 10 minutes. So it's a prediction more than a hypothesis. And sometimes it can't be proven. So for example, let's use the bees example. Bees were exposed to insects. If bees are exposed to insecticides, then they will have lower body weights. Okay, cool. You can test for that, but you're not asserting something, you're predicting something. So it's more on the wording than anything. Say if I also put the bees are declining because of the sun. Is that a fair hypothesis? It's not a clear one. It's not a good hypothesis, because yeah, the sun, how can I prove it's the sun? They are dying because of exposure to sun, because the heat has gone up. Okay, now we're talking. So please keep this in mind. For you guys at the undergrad levels, not that much of a problem, but for people in graduate level, it is. Try to keep your hypothesis as clear as possible, as detailed as possible. Try to avoid if-then statements. Try to avoid looking like a psychic, because usually in science we just like, this is how it is because this happens or that happened. We're not fortune tellers, sadly. How did the scientists test their hypothesis? Well, in this case, they designed an experiment and they determined the bee body weight and used it as a proxy for their health. For example, skinny bees are sicker than fat bees. So bees that weigh more than 1 pound are healthy. Bees that weigh less than 1 pound are unhealthy. And then they use that to determine if the bee population was sick or was healthy. And for example, we can expose the bees to pesticide and see if their weight went up or went down, and then determine if they were healthier or not, or the pesticides made them sicker. And of course, you're gonna have a series of steps here, like determine the body weight. They trapped and measured the bees at different locations. They sampled the amount of insecticide. So they are going to be working with different elements of the experience. They're gonna be manipulating different stuff. And that stuff that they're gonna be manipulating, and that stuff that are gonna be reacting to that manipulation, are called variables. We have a lot of variables. We have more than two. Usually at an undergrad level, we teach 2 to 3, like independent variable, dependent variable, and the control variable, or the control group. For now, don't worry about it. We're just gonna talk about independent variables and dependent variables. For some people, this is super easy. This is obvious. For some people, like for me at the beginning, that was super hard. It was very difficult, but don't worry, I will make you guys variable experts by the end of the year. Actually, I will teach you a couple of tips and tricks for identifying variables, and they all stem from knowing what they mean. So for example, an independent variable is something that you can directly manipulate, while an independent variable, you can't really manipulate that. You're not God or somebody who's gonna say the bees will die and then all the bees die. No, usually they die because of, or they live because of a response to something you manipulated via the independent variable. So we're gonna jump off the bee example for a moment, and I'm gonna teach you, or I'm gonna show you a very simple experiment. I wanted to know, why do I sweat? Why do humans sweat? Humans sweat because they're hot, or do humans sweat because they're cold? That's a valid question. I mean, that's not a valid question, it's a scientific question, but you know, for this example, it is. Do humans sweat because they're hot or because they're cold? How can we test that? Well, I'm not gonna go in and say, I'm gonna be hot now, or I'm going to be cold now. No, I'm going to have to manipulate something to make me either hot or cold. And in that case, that will be the temperature. That, what we manipulate, is our independent variable. So in my temperature experiment, I'm gonna go ahead and put the temperature as low as possible, and I'm not gonna sweat. And I'm gonna put the temperature as high as possible, and I'm gonna start sweating. So my body is going to respond to that independent variable. I will not, or I cannot manipulate my own body temperature at will. But external forces that I can manipulate will create an effect on me. Will it be the desired effect? Will it be another effect? I don't know. It all depends. But the independent variable is that what we can always choose, that we always pick it, like we always manipulate it. It's easy to work with. Another example, I want to see how much people gain weight for eating fast food. That's good. That's a good example. I cannot control the weight of the people directly. I cannot go to the people and say, you're fat, you're skinny, you're fat, you're skinny, you're fat, you're skinny, and they're gonna automatically be fat or automatically be skinny. But I can control their diet. I can control which type of food I give them. I can control if I'm gonna give him 2 Big Macs or 1 Big Mac or 1 Baconator or a salad. That is my independent variable. The food, I can control the food, but I cannot control the response from their bodies. So that which I cannot control, but will respond to the changes I make to the independent variable, will be the dependent variable. Now, jumping back to our little bee example, an independent variable would be the amount of insecticide I use, the pesticide I use. So if I got 3 groups of bees here, I put a lot of pesticide here, not so much pesticide here, and nothing here. I can decide the amount of pesticides I'm gonna be using at the different places. The thing I cannot control is if the bees are going to die, if the bees are gonna get skinny, if the bees are gonna get fat. They will react toward the different changes I make of the pesticides level, but I will not be able to control their weight directly. I will not be able to control their survivability rate directly. I can do so indirectly by manipulating independent variables, but I cannot go to the bee and say, you're gonna be skinny, you're gonna be fat, you're gonna be, because I say so. No, it's not like that. But I can say there's gonna be a lot of pesticide here, just not gonna be pesticide because I say so. That I can manipulate. So that's pretty much the main difference between independent or dependent variable. If you guys still don't understand it, if you guys, again, this is not, they're not expected to learn this right away, but please send me an email when we see each other in person. Hey, Fernando, could you give me another example? I have a lot of examples, a lot of experiments to show you. So don't worry about it. And again, you guys are gonna get the hang of it, I promise. Don't worry about it. And again, just to reiterate here, the dependent variable is influenced by the independent variables. The changes I make here in the independent variable will affect the changes I will observe in the dependent variable. Now, cool, Fernando, we did all that. You guys did it, you got all the data, but we have a lot of field work, we have a lot of numbers. We're going to have to then organize all of that. And that's a very important part of experimental design that people don't think about. And again, I'm just gonna tell you a little bit of an anecdote here. A lot of scientists, a lot of them, I will say more than half of them, create a perfect experiment. We're gonna see fish population, we're going to measure, we're going to go here, we're going to see all the fish, we're going to count them. They don't think about this part. Getting all that data together, compiling years and years and years worth of data into one single Excel sheet, into one single graph, and that actually takes the most amount of time. And my research could actually be done in 2 months, but because the people didn't compile their data correctly, it took us 2.5 years. So compiling your data, the way you pick your data, the way you are organized with your data, and the way you know how you're going to present them or how you're going to organize them will really affect how well or how quickly will you be able to do an experiment. Imagine if you're a doctor and you're going to operate, and the guy is there on the emergency room or whatever, on the operating room, and you're like, okay, he's there, they're already sleeping with the anesthetic. What am I gonna do now? What does the guy have? You didn't do that before you saw the guy, so you're just winging it right there, and it's not gonna be cool. If you're a business major, you're going to a business meeting and they want to see if your company earned money or not, but instead of showing them a single graph with all the data organized, you show them a bunch of stuff because all the data was disorganized, and you show them 5 different graphs that actually tell nothing, and you're probably gonna get fired. Hopefully not, because I know you will learn from this one. And if you're a doctor, you'll learn to come prepared to take account every single moment of the experimental design. As a doctor will take account every single part of analyzing a patient, diagnosing a patient, treating a patient, and then, operating or whatever the part comes. I'm not a doctor. I'm not a medical doctor. But yeah, this is something very, very important. How do we show the data? And usually we do it in terms of graphs, maps, diagrams, because people are kind of lazy, myself included. I don't like reading that much. Funny, because I'm a scientist, I do read, but if you can tell me something with an image, I'll really prefer the picture rather than reading 5 pages of what does this picture mean. I'm sorry, there's my dog back there. Yeah. Her name is Kenepa. She's a rescue. So, she likes to get a little bit of trouble. So sorry for the segue there. But yeah, when we're showing data, we want to be able to show it in the most concise, precise, and easy to understand way as possible. 90% of you will really prefer an image explaining something than 5 pages of me trying to explain something. For example, let's take this graph over here, and we see an X and a Y, and wait, Fernando, I'm lost. I've never seen this before. What does this mean? Easy. We already know how to identify dependent and independent variables, right? Good. So we have the data that we have collected from the dependent and independent. Okay, if I put the temperature up, this is going to happen. This is the amount of bees that died. This is the amount of bees that survived. If I put more pesticide, these are the bees that got skinny. These are the bees that got fat, whatever. We have the data, we have our variables, and we have the results from those experiments. So we're going to put them, usually we put them in computer programs like Excel, and we're going to choose the numbers that we're going to use. Usually, again, we get those results in the experiment. So the first step is, all right, let me remember, this was my independent variable and this was my dependent variable. My independent variable will always go on the x-axis. This is the x that goes right here. The x-axis, meaning the horizontal axis, will always contain information from my independent variables. This could be the amount of pesticide I put in. 1 gallon of pesticides, 2 gallons of pesticide, 3 gallons of pesticide, all that, 9 gallons of pesticide. And on my vertical axis, my y or my y-axis, sorry, y is in Spanish, my y-axis, we're going to put our dependent variable. So for 1 gallon of pesticide, 95 bees were alive. On 2 gallons of pesticide, 31 bees were alive. On 4 gallons of pesticide, 50 bees were alive. So again, this is the thing we can't control. This is the thing that is going to respond to the independent variable. So it's simple. Our X, our horizontal axis, will contain information from our independent, and our vertical y-axis will contain our dependent variable information. I use the examples of the bees, but I can also use any other example. Let's say this is PlayStation. I'm a bit of a gamer, so I love game consoles. So for example, this is PlayStation sales for the last 8 years. So we got year 1 through year 8, and this is the amount of consoles we sold. But Fernando, we can't control years. I'm not gonna say 2019 is today, and no, that is not the point. We can control which years we are going to take a sample. So we are going to take a sample in year 1, we're going to take a sample in year 2, we are going to take a sample in year 3. The amount of years I'm going to be sampling, those are the independent variables because I am manipulating them. The things I can't manipulate are the amount of sales. So for example, on year 1, I sold 94 PlayStations, but on year 2, I sold 32 PlayStations, on year 3, so on and so forth. So my dependent variable will be dependent on the year. So will it be a high earning year or will it be a low earnings year? Will it be a high probability of success rate of the cure, or will it be a low probability? Whatever. I'm trying to put, examples here from my business students, but also, for medical or ecological reasons, but it's pretty self-explanatory. In Excel, our independent variable, our x-axis, the information we will always input them on the leftmost column and then followed by the dependent variable. If we were to switch them, if we would have put the y column here and the x column here, we would get a mess of a graph. It will not be showing the data correctly, and you wouldn't even be able to explain it. So always remember your independent variable is going to be on the leftmost column, and then your dependent variable is going to be right beside it. This data could be anything you want. In our example, it's going to be honeybees, which is what you're going to be working with later on. Now, another important step is graphing the data. There are a lot of graphing probabilities. We can do a pie chart, we can do a bar chart, we can do a line, we can do a scatter plot. And this is something that I'm gonna tell you that is a little bit, not divisive, but it will open your eyes a little bit and it will ease you somewhat into the graph selection process. You can actually, there's no way of going wrong with picking the charts. Any chart, as long as it shows the data organized correctly, meaning that you have your independent variable on one side and your dependent variable on one, you can put whatever graph you want. You're always going to be correct as long as you're showing the necessary data. Now, where do people fail, and where are you going to really be tested in the classes? Picking the best one, not the right one, because all of them are right, is picking the best one to show your data. For example, let's use this chart over here and say that the light blue are PlayStation sales and the deep blue or the dark blue are Xbox sales. So we got on year 1, PlayStation outsold the Xbox. On year 2, Xbox outsold the PlayStation. Year 3. So for example, if we want to do a one-to-one comparison, what happened this year between this one and those other 2 or those other 4 consoles or whatever, we're going to use a bar chart. So it's easier to see, here PlayStation outsold Xbox, here Xbox outsold PlayStation. But if we want to see trends, we're going to use lines, because it's easier to see, okay, if this is the Xbox sales, they went up from year 1 to year 2, but then they went down and then they went up again. And for PlayStations, they went down from year 1 to year 2, but then they picked up again. And again, this data could be whatever you want. If you wanted it to be obese versus skinny people, this is there are more obese people in this state than skinny people, there are more skinny people on this state than skinny. And then you can put the obesity rate right here. You know, as we move towards the years like from 2004 to 2006, the obesity rate increased, but then decreased this year and then increased again. Again, it all depends on the type of data you want to show. And sometimes we will choose the incorrect or the not incorrect, but the not necessarily the best one. So for example, here, I'm trying to show a trend. I'm trying to show this using bars, and you can't actually see them. Again, for example, here we have ketchup consumption versus weight gain. So which one is ketchup? It's light blue. I can't see them very well. What happens here if I consume? I don't understand it. Right here, I can't really see a trend. I can't really see a correlation because we have so many bars. We have a lot of information going, and I'm like, oh no, I'm kind of lost. And sometimes we even use a line, and it's like, oh wait, what's happening here? This is a little bit more understandable, but still, it's not the best one. For example, here it says that if we go down on ketchup consumption, our weight gain will go down. But if we go up on ketchup consumption, our weight gain will go up. So we'll gain more weight the more ketchup we consume. And again, I get it because I work with this for about 5-6 years. But people who don't know about your study, who don't know about science, and you're trying to teach them, using this is not going to be the best method. And probably you're not going to get published anywhere. Now, if we use here, this is a scatter plot. The scatter plot says, forget it, I'm not going to try to put all the little dots together. I'm not going to throw a line. I'm just going to throw all the dots there, and I'm going to do what's called a trend line. This line here is very important. The trend line, well, it does just that. It tells you what the trend is. So if the trend line is going upwards, it means that there's a direct correlation, meaning that if it's going up, well, the amount of ketchup that I eat per week, if it goes up, my weight is going to go up. So if it's up, it means that as my independent variable goes up, my dependent variable will also go up. So it says here that the more ketchup I eat, see, servings of ketchup per week, it increases. The more weight I gain. This is the general trend. Sometimes it might go up, sometimes it might go down. It doesn't matter. The general trend, the overall trend means, or it lets us know that there is a positive correlation there. There is an increase in something will lead to an increase on another thing. If the line was going down, it will mean the opposite. An increase in ketchup will be a decrease in weight. So the more ketchup I ate, the skinnier I got. This will be true if the line was going down, but since it's not, since it's going up, the more ketchup I eat, the more weight I'm gonna gain. I know I'm being a little bit like, you already explained it. Trust me, you guys are gonna need those explanations in the future. And I'm just making sure that everybody understands it. Now, for the homework you guys have, or for the activity you have planned for this week, other than seeing this video, you're going to use some data, some B data that we have on Canvas, and you're just going to do graphs depending on the instructions, what the instructions tell you. You're going to do the necessary graphs. Excel, you're going to be using Excel. So if you don't have it, don't worry. It's free for OU students. Just go to the OUIT webpage, just put Excel OUIT, and you're going to have a download link there. So yeah, if you have any problems downloading Excel, let me know. I'll help you guys out. And Canvas, you're going to see a video instruction on a graphic and video assignment instructions. Well, sorry. And it's a file is going to be available on the Canvas webpage, probably available now. You can use Google, you can use YouTube, you can help each other out if you want, but I do want you to upload that assignment separately. You still haven't met your lab partner, don't worry about it. I will do that when we see each other in person. For now, I only want you to do your own work, forget about your lab partner for a moment. So I want everybody to hand it in separately. But you can help each other out. If there's a friend on the class, you can do them together. I don't care. As long as you do it by yourself and you understand it. More than do it with somebody, you can do it in a group. As long as you understand what you're doing, I'm fine with it. You have 1 week to complete this assignment, meaning that you're gonna probably have this video uploaded by Monday. So you need to do it by Friday. Here, Just a little bit of a summary. The due date is August 28th at 12 p.m. And you're going to go to OU Canvas. Under the modules tab, you're going to see week 824, all students, and you're going to see under the assignments tab, the graphing assignment, the document, the data, the data that you're going to be using in Excel, and a video tutorial on how to make graphs in Excel. And then you're going to be able to upload your assignment here. You are not going to send me that assignment to my email. I don't want to see it in my email. I want you guys to upload it here on Canvas. So you just drag and drop the file from your computer there. If you have any doubts, if you have any problems during this assignment, please let me know. I'm here to help. I'm eager to meet you guys. I'm very excited to be teaching at OU. If you're a freshman, I'm glad that I got to meet you as a freshman, and hopefully I make a good impression for all the professors on behalf of the university. If you are on your last year, don't worry, we'll get through this. You're gonna graduate. And if you're undecided, don't worry, hopefully I'll let you know, or you'll be able to find out if you're passionate after this course with me. So yeah, again, looking forward to meeting you guys. If you guys have any doubts, again, I'm just gonna quickly go over the schedule just for Pete's sake. This week, the week of the 24th, everybody's online seeing this video. For this Friday, the 28th, I want you guys to upload the B assignment that's on Canvas under the modules tab. If you have problems, again, send me an email. Next week, I'll be seeing Group A. This group I will be seeing on Thursday, and this group I will be seeing on Friday. While this group will be doing online work, the same as this group. After that, we have a week off. Then the people who saw me will stay at home and do online work, and the people who did online work next week will then do wet lab work with me, and will finally get to meet me. So yeah, other than that, if you guys have any questions, the quizzes, which is mostly the questions I get about, they are 10 points each. They're very important for your grade, but you'll get through them if you study. If you do the pre-lab sometime, you're probably going to get 10 out of 10, 9 out of 10 in almost everything. And the lab summaries, keep on top of your work. Don't let stuff bundle up. Always keep an eye on Canvas. Check regularly, at least once a day, just in case. And please, when you have online assignments, remember it starts on Monday and it ends on Friday. So you'll have till Friday to do it. Please upload it on time. So yeah, looking forward to meeting you guys. If you have any questions, just send me an email. And cool. Other than that, see you soon.